This short video is going to show you how to figure out the theoretical yield using stoichiometry as opposed to requiring me or a table to provide you what the answer should be. So to do that, you actually need the data from the lab. So we're going to use the reaction that you're very familiar with, silver nitrate plus copper. What I want to focus on, however, is the mass of the silver nitrate as the way of doing it. I know that we also weighed out copper, and technically we could have used the mass of the copper, but remember, to get the mass of the copper reacted, we had to subtract, and there were all sorts of unknowns. Did you get all the silver off the copper and so forth? So in order to avoid any of those possible errors, we're going to go with the for sure mass that we measured, and that's the silver nitrate. The other two pieces of information that we need are obviously the beaker with the silver, and then what was the empty beaker that we started with. So these would be the three pieces of data that we need. So we can figure out the experimental by simply subtracting like you did before. So the experimental yield of silver is simply going to be the beaker with the silver minus the beaker. So we've got the 148.09 minus 147.83 gives us a mass of 0.26 grams of Ag that we got from the experiment. Okay, so now this is what we got. How much were we supposed to get? That's where the mass of the silver nitrate and the balanced equation comes in. So theoretically, if we had 100% no errors, 100% yield, we would use 0.52 grams of silver to figure that out. So, or silver nitrate rather. So we have 0.52 grams of silver nitrate. We're going to do a mole problem in order to get 2 grams of silver. So I know that for every 1 mole of silver nitrate, I've got 169.9 grams. I know that from the balanced equation, the mole ratio is 2 to 2. And then I've got to convert from moles of silver to grams of silver so that I can compare to my experimental. So I know that a mole of silver is 107.9 grams. So when I do that math, I find out if all of the silver nitrate that we used reacted and there was no error at all, the mass I should have gotten was 0.33 grams. Now I can go on and calculate my percent yield or my percent error, whatever it is that I'm interested in. If I do my percent yield, I can say that I've got 0.26 divided by 0.33 times 100, and I didn't calculate this one beforehand. I get 78.8% yield, which is not horrible, but it's not great. But if you think about all the things that we did during the lab where we could have lost silver, you know that this is not too bad of a number. All right, so once again, experimental yields you're still getting from your data. There's no way around it. You have to use your data. But to get a theoretical yield now, you're going to use some starting material. How much did you use to start? If all of what you started with got converted and you didn't lose any, so if you were 100% efficient, how much product should you get is your theoretical yield based on a mole problem. So that's how you get theoretical yields from stoichiometry information.